who's here, but you can kind of hear me here. Um, all right, let's get started. I think there's questions over here on the side over here. This is totally different for me. Obviously, some of you are watching live right now, and that's fantastic. We're going to try to really work through this, and hopefully it's going to be helpful for you. One thing to really note, if you're joining us, is the fact is that obviously since this is on YouTube, we just need to be careful on what we put on the side for questions, and also we'll be sure to answer the questions appropriately there. If you are here, if you could just throw down a question, or if that's not working, then you could just shoot me a text with a problem number that you have on there. And that problem number will be helpful for me and what problems we need to go through at this time. And this is not podcasted. This is not something that I want to podcast, but what it does allow us to do is just, again, go through some questions together without using the Blackboard program that you have to download software for. So again, we'll rock and roll. You have anything right now? I see that there's 0 viewers. Then we'll keep it going. All right. Very good. If you have a question, just throw it up on the side. All right. So another couple things too I want to make sure on is I think it's coming through here. Just make sure. Sweet. 0 viewers. It's good. This is really pathetic. Should I sing a song? I'm literally being live broadcasted right now on YouTube, and no one's watching me. 4 viewers, yes! Finally, I feel popular. I was about ready to sing a song, and that would have been really bad for you. You had a song on that and saw me. So 4 viewers. I think I'm on the side, over here. I think you're able to answer questions over here on the side. Correct me if I'm wrong. If you're not able to do that, I apologize. But this link should be good. If you could for me, if you can't hear me or if something's wrong, please, you could text me at 770-757-2240. Again, that's 770-757-2240, just to make sure that I'm good to go on there, okay? We're going to take a look at some stuff in just a second. If you've got a question, you can do 2 things. You can either put a question over on the side, or I think the question and answer over on the side capability is on there. Again, this is our first time doing this, so we might need to kind of work through the kinks and stuff, and that's okay. But what we'll do is, if you have a question, put it there, or you can text me, again, at 770-757-2240. And we'll go from there. So, when I can hear that, if you can't hear me, please let me know. Again, to all my YouTube followers out there that's subscribing to my channel, we can do it and go from there. All right? All right. My little back there. Perfect. Yeah, here we go. Question number 12. All right, well, we're going to check this out. Let's see if we can work this out here. Let me go here on the side. Awesome. And if you could, when you put down what question it is, it doesn't tell me who you are. If you could put down who you are, just so I know who's here. Even if you sign in and say, hey, this is Coach Jay, this is such and such, that'd be great. That just helps me out and goes from there, all right? Bailey, sweet. Oh, you're watching. Awesome. Hey, people are texting in. This is great. This is going to be awesome. I'm excited about this. All right, let's get it rolling. Now, this is going to be a little different. Hopefully this works for us. If it doesn't, I apologize. All right. Let's look at this. Yes, can we do this? Can we start screen share with this? Yes. Can you all see that? I hope you can. All right, let's look at number 12. Hey, the easiest thing that's going to happen for me right now is I can't see the question and answer on the side. So if you could text me in, text in, again, 770-757-2240. That just allows me, when you text in, to be able to get what question it is, put your name with it. Helps me go from there. Here, Bailey. Bailey's on right now. A little shout out. We'll start with that, and we'll go from there, okay? All right. Let's go to this one. Number 12, okay? Number 12. Take a look at that. Let me get my iPad up on that number 12 there. Excellent. Go this way. All right. So the question comes up on this one, and it's a good one. And it states this. It says, all right, if y equals 5 tangent of x minus pi over 4, this is, I tell you what, it's one of the toughest problems. Y equals negative 5 tangent of x minus pi over 4, okay? Again, this is a tough one. When we set this up, what we want to do is we have an x and y axis, right? X and y axis. And let me also say this. If you have a question on this, regarding this, please ask me at any time. I'll have my phone here, my iPad here. So, like Griffin right now just sent me. Yeah, Griffin's got a little shout out there. You know, there I got people coming in. Bailey, yeah, obviously, just with one, she needs help setting it up. So again, just text in, it'll be live, and we'll go from there. My Twitter followers. All right, now this is one of the ones that I feel kind of nervous on. And going into tomorrow, this is one of the few that I feel as though we're going to have maybe some struggles on. For instance, with tangent, I know that we have tangent of this right here, and you'll notice that when you have tangent of this, that we do it a little differently. We don't find what the period is or the phase shift. More or less now, we're trying to figure out what the asymptotes are. So in doing that, what we want to do is we want to take x minus pi over 4, and we're going to do that twice, one on one side, we're going to have one on the other. And with tangent, and this is very important, you need to make sure you know that it goes from pi over 2 and negative pi over 2. Normally, the period is pi. Notice it goes pi over 2 to the right and left, okay? So understand that. So when I solve for this and I use this, I don't solve for C over B phase shift, but rather I find out what it is when I set it equal to pi over 2 and negative pi over 2. So in solving for this, we're going to add pi over 4 right here on either side. Okay? Again, pi over 4 on either side. All right? So when I set that up now, when I get that, I end up getting x is equal to pi over 2 plus pi over 4. If I get a 4 on the bottom, remember, try to get common denominators. You got to multiply by the top, which would be as 2 pi over 4. So when I add this together, 2 pi over 4 plus pi over 4 should get me 3 pi over 4. Okay, that'd be my first answer. The next one, same thing. We want to get a 4 on the bottom. If I multiply by 2, I get a 2 on the top. So negative 2 pi plus pi over 4 should get me negative pi over 4. So again, a good question that Hunter had in class today was the fact that, you know, when you have a graph, how, you know, what is the, how do I set it up? Well, again, it's going to be different for each person, and I'm okay with that. For instance, because I know it has an the asymptotes are 3 pi over 4 and negative pi over 4, I might want to say that for every tick mark, I'm traveling pi over 4. That may help me. So that means that right here, this would be negative pi over 4, and I'll kind of write that in. And then this right over here would be 3 pi over 4. Okay? Should be 3 pi over 4, not 2. So I have pi over 4, 2 pi, or you could say pi over 2, or you could say 2 pi over 4. We'll say pi over 2 here, and then 3 pi over 4. So right here, these are my asymptotes. That's really the big part of setting it up. If you can get to this part, if you know how to do this part right down here, starting it on this side and this side, you are golden. Because once I do that now, we have the beginning and the end. And just like before, we're going to get the middle. Okay? When I go to the right, normally on a positive way, it travels to the right, up. Yeah, I got a text in here. Why is the period not pi? Again, I don't care about the period right now. Okay? I don't. My big thing when I'm doing it is when I get the period, I really don't care about it. I just don't. It's not a big deal to me. But, and again, hold your breath, because we will eventually. But right now we're just solving for the asymptotes. The asymptotes will lead the way. If we can get what the two asymptotes are, 3 pi over 4, negative pi over 4, I can solve for the period. Okay? So I don't need to do 2 pi over b. All right? Again, you wouldn't do that anyway, because tangent normally would be have a pi of, it would just be a period of pi. But right now that's not a huge deal. So once I do this, the tangent would normally rise to the right and fall to the left. But because it's negative, you'll notice that it now falls to the right and goes up to the left. Okay? So we got to be careful. So what I do is I put my x's at the quarters, okay? And because of this 5, that means when it goes, again, usually it rises to the right. This time it's going to rise to the left. That means at our quarter spots, it's going to go up 5. Okay, and again, these will be smaller. That's okay. So I'm going to go right up here. And when it goes to the right, it's going to fall down 5. It'll be right down here. So this, again, would look something like, kind of go up this way, approaching, and this would come down this way. All right? So it should look something like that right there. Now, if they said, do 2 periods, we might have to extend it. 3, 4, do another asymptote, hit the middle. This time you don't have to be as precise, just kind of mirror it. That's all I'm looking for. If I'm looking for 2 different periods, meaning all I'm doing is just copying it twice. It's repeated over and over again. Now, the question about period, we're going to do that at the very last thing. It's going to be the very end. So when I look at that, I look at it and see, all right, if I start at negative pi over 4, I end at 3 pi over 4, how much did this graph travel? Well, if it goes negative pi over 4 to 3 pi over 4, you'll notice that I have pi over 4 to the right to 0, and then I add 3 pi over 4 for a total period, and you can just put this on the side. This is more for your sake. The period would be a total traveled of pi. Here's a hint. If this x right here is 1, if it's 1x, the period will always be pi. If it's anything greater or less, that period may vary. But for right now, again, I would save the period for the very end. The most important thing is to find the asymptotes and then go from there. Also, if you were to do cotangent, reminder, you wouldn't set it to pi over 2 and negative pi over 2. It would now be 0 and pi. Okay? God, I think I've got a question yeah, the period is pi. Okay? The period is pi. But again, I don't need to find that right now. That doesn't help me graph it like cosine and sine and secant and cosecant. What I want to do is find the period at the very end. So that's something that I finish off with. I don't start with that. I want to make sure that first off, I know where the asymptotes are. I know where the middle is. That becomes fairly easy. I graph the quarters. If it's a reflection, I adjust accordingly, and then I go from there. But then at the very end, that's when I do the period. Okay. All right. I hope that makes sense. I know someone is texting me 404 something 404 number here. That's you. And if you understand that, just put I understand down below. That just helps me out for sure. Okay. Awesome. Awesome, awesome. I see a lot of people here that are texting in. Again, if you're just arriving, if you have a question, text me at 770-757-2240. If you have a problem with me going over one, maybe for some reason you struggle, please make sure you stop me in the middle, my Twitter followers. Hopefully you like this. I think I like this a lot better than what we have been doing, and hopefully we'll continue on this route. Okay. Great question. Why is it not in the middle? Well, because, and again, this is more or less hidden. We don't necessarily need to find the phase shift, so to speak. But, for instance, if it's x minus pi over 4, what I do is I use that to set it equal to pi over 2 and negative pi over 2. And when I solve for that, whatever I find x is equal to within both equations, within pi over 2 and negative pi over 2, those two automatically take into account what the phase shift is. So for some reason, if let's say if it transfer in pi over 4, you'll notice, and I don't want to get too far into it for the person who asked this, but if it goes to negative pi over 4, because this is negative, it's as if it's transferring over to the right pi over 4. So it's as if I went to the right pi over 4, and now again, you don't have to know that. That's not something that I'm wanting you to know. I would prefer you understand what's in red below rather than know that. But just know that because of the phase shift, again, we don't need to know where the phase shift went. I just want you to be aware that when I do this, when I solve for it, I'm solving for the asymptotes of pi over 2 and negative pi over 2. Okay? I have another question in, and I see a lot of people say I understand, so I'm guessing we're moving in the right direction here. Totally appreciate y'all being here. I can't say that enough. Again, we'll keep working on this, make sure that if there's anything else we can do to try to review in a better way, we can. But I think that so far, so good. Hey, Bailey, could you please, Bailey, I know that you said you need to do one. I think you said number 1. I think think that's right, but I'm not 100% sure. So what I'm going to do is I'm going to do number 1 just to be sure, and then after that I just got a text, can you do number 8? And please. So I will definitely do that. I'll do number 1, and then I will do number 8. Okay, it says this. There's a 20-foot ladder up against a house. Okay, all right, 20-foot ladder up against a house. All right, got this ladder here. Good. All right, right there. Hopefully not putting up Christmas lights. Oh, yeah. I'm sorry. The person who just texted me, oh, so you're finding the middle of the asymptotes? Just so you're aware, you're exactly right. What you just said is exactly right. Middle of the asymptotes. Nicely done, okay? Nicely done. Will that be on the test? Yeah, that one will be on the test. There will be a tangent and a cotangent on the test, okay? All right, Griffin, I heard you. Let me do this one first before I get to those other texts, okay? 20-foot ladder is up against a house, okay? The question becomes that when I set this up, it says it's 8 feet from the base of the house, okay? So from the base of the ladder to the house is 8 feet, okay? Now, the question becomes is what is theta? What is the angle of elevation? Now, just so you know, if I were to ask for the angle of depression, the angle of depression would be in this area here. The angle of elevation is right in here. Understand this, that both are the same. So if I ask for one, be the other. If I ask for the other, obviously be the one, okay? So when I'm setting it up, we know that we have the adjacent side and we have the hypotenuse side, okay? So if I'm setting this up, we know the opposite sides across. If I'm setting it up, I have adjacent and hypotenuse. So what I could do is say cosine of theta equals my adjacent over my hypotenuse. Well, because I have my adjacent side being 8, my hypotenuse is 20, what I could do is have cosine of theta equals 8 over 20, but I don't want that. I don't want theta by itself, so I can get cosine inverse on both sides to where I cancel out, to where theta is equal cosine inverse of 8 over 20. Again, the big thing when I come to a problem like this is to be able to look past all of the stuff with the word problem and really get past to where you can get a picture. I'm telling you, if you get a picture, you're going to be okay. But the problem that many of you run into, maybe even I run into sometimes, is what does the picture look like? And if you can do that, you're going to be successful. Okay? All right. Billy, if you have a question on that. All right, Patrick, sweet. Awesome, man. I appreciate those questions coming in, Patty. Appreciate you, man. Awesome. Bailey, if you have any more questions on that, you could text me. If not, no worries. You don't have to text me on that. I'm going to go to number 9. Number 9 is kind of a harder version of number 8, so Griffin says. And we're going to look at that one. Let's look at that. Okay, so number 8 becomes really easy because all you need to do when it's an actual value is we just cancel out. So like 8a, if you look on the answer sheet online, 8a would be like square root of 3 over 2, and then b would be, I think it's negative 3. But like when we come to 9, 9 becomes tricky because we have 2. We have sine inverse of sine of 7 pi over 6, okay? And another one is cosine, or arc cosine, of cosine of 2 pi over 3. Now, when I come to a problem, such as this one, and I have the inverse of the sine inverse of sine, I could cancel out. Same thing with arc cosine and cosine. Those can cancel out. So when I do that now, I'm left with, on the top, 7 pi over 6, as well as 2 pi over 3. Now, on 8, you could just simply leave it, and you're good to go. But a lot of you will try to circle this and try to be done with the problem. But the issue is that we have ranges for our inverses. Remember with cosine inverse is 0 to pi, okay? 0 to pi. If it is sine inverse or tangent inverse, sine inverse or tangent inverse, okay, it will end up being pi over 2 to negative pi over 2. So if I don't have a value between 0 and 180 degrees with cosine inverse, I'm wrong. I need to fix it. If I don't have one within pi over 2 or 90 degrees and negative degrees, I need to fix that as well. So my big thing is I've got to make sure that what I have is within my range. That's very important. So I look at 2 pi over 3. Again, to put in context, if I were to change this to degrees, I'd put 180 in for pi. 180 times 2 is 360. 360 divided by 3 would be the same as 120. So 120 degrees would fall somewhere up yonder, okay, way down yonder on the Chattahoochee. Oh, how much I would wish that muddy water meant to me, okay? So 2 pi over 3 would be right there. It is between 0 and pi. So because of that, you are good to go. It falls in, so 2 pi over 3 is a sufficient answer, okay? 7 pi over 6 is a little bit different. Because if I look at that one, I give it old stare down, give it the old googly eye. I look at it, 7 pi over 6 would actually be over in this vicinity. 7 pi over 6, if I were to do it, would be 210 degrees. If that helps you to put it in degrees, absolutely fine, okay? All right, so if 210 degrees is here, again, this is 30 degrees away. It's a 30 degrees reference angle. And that helps me because what I'll do is I'm going to give my point, which would be square root of 3 over 2 with a negative square root of 3 over 2, and negative 1/2. The problem, though, is that this blue line does not fall within my range of the first and fourth quadrant of 90 degrees and negative 90 degrees. It just doesn't. So in order to find that, what I have to do is say, all right, is there a place where sine is going to be negative 1/2 that's outside of the third quadrant? Well, I know that sine relates with y. And because sine, the only place sine is negative 1/2, goes downward, what I could do is make it to where it's in the fourth quadrant now. And the point now would be square root of 3 over 2, comma, negative 1/2. We know that, again, this would be a 30 degrees reference angle. Now, I know a lot of people, even in this case, might look at this and say, oh, I get it. Oh, it must be 330 degrees. Well, that's actually incorrect. Even though yes, it falls in my range, remember, it's got to be 90 to negative 90. So not 330, we would actually say negative 30 degrees, or, because I like radians, negative pi over 6. Okay? All right? Again, I hope that helps you and that we're good to go on that, all right? All right. Hopefully you're not hearing anything in the background. If you're hearing anything in the background, just text me. I think everything's good. I just hear some noise in another room, so if you hear anything and it's picking that up, let me know, and I'll try to switch that. But if not, then don't feel like you have to text me there. Okay? If there are questions, please text me in. I don't have any questions in here, so that means that hopefully we are good. Bailey is good. Shout out there. Shout out to Patty. Shout out to Griffin. Some people I don't have your numbers for. I apologize there. But shout out to you too. I have a lot of people. I have 3, 6, 7 people in the review so far at least. So thank you so much. All right. Thank you very much. I see number 5 on the review that I'm going to do, and awesome. All right. Let me go back to this one. Yeah, I could go. Okay. So right now I'm going to get to all these other problems. Number 5 I will get to. Someone said, Coach, you lost me on the graph. So I want to. Just to make sure that we're good here, okay? Let's do this. Let me erase this bad boy. Give it a little erase now, okay? All right, let's take a look at this. I'm guessing that the first one we're good on, okay? I mean the second one. I think the second one we're good on, okay? I think this other one, oh no, that's fine. I saw someone asked, hey, could I come in the morning so that I don't slow everyone down? Again, that's no problem. You can come in the morning tomorrow. That's no problem. But also, I'm going to try to explain it one more time. If I don't get it this time, maybe I could talk one-on-one with you, and we can go from there. Okay. All right. So let's say we have 7 pi over 6, and okay, so we have 7 pi over 6. We know that it's going to be in this vicinity. The reference angle will be 30 degrees. Okay. All right. 30 degrees. So because this is 30 degrees, the point is negative square root of 3 over 2, comma negative 1/2, and you can. Again, the unit circle kind of will show you that. Remember, you will have the first quadrant for the unit circle. But remember, my question is where is sine going to be negative 1/2? Okay? Where is sine also negative 1/2? And the only place is over this way. Okay? Again, this would be 30 degrees right here. to be 30 degrees, but this is another place as well. My question is which one falls in my range? Well, the only place that it can fall in my range is from positive 90 degrees to negative 90 degrees. So now, since, again, I'm looking at this and I know it's at 30 degrees, I can now travel downward and say, all right, well, what's the same as this for negative 1/2? I could say negative 30 degrees. Well, how do I change that to radians? I can multiply by pi over 180 to get negative pi over 6. So now negative pi over 6, the sine of negative pi over 6, and sine of 7 pi over 6 is the exact same thing. These two are the exact same thing. The only difference is that in order to, with our inverse, sine inverse, negative pi over 6 falls in my range. And again, so that's kind of the big thing to know, is that they're the same. They are the same. Sine of those, you'll get the same value. But with the inverse, it must fall in my range. Okay? Remember, if we fall outside of that range, you'll have errors, meaning that we don't have values that are outside of that with it. Okay? All right? All right. Awesome. I see number 5. Number 5 is a good one. I'll do that one. And yes, someone asked a good question. Could we, is there an answer sheet? The answer sheet is actually on Haiku. If you go to Haiku, click on chapter 4, it'll be right near the top. There's 3 pictures up there that gives all the answers. At least prepares you. You might have to do the last step, but it gets you to the last step there. All right, let's look at number 5. Okay, number 5. Did we already do number 5, I wonder? No, we didn't, because that was the one that was like really tough, okay? Let's take a look at that one. This one, there will be one on the test. Like this one. Cosine of arcsine of x minus 1. Okay? Got a fly flying around me. Shoo fly, don't bother me. All right. Arcsine of x minus 1. Since we look at this, my goal is this. I look at it and say, what is cosine of the angle formed when I get arcsine of x minus 1? Well, again, though x minus 1 has a negative value, overall this value is positive because as I look at it, you'll notice there is no negative on the outside. So knowing that, I know I'm going to have to be in the first quadrant. Okay? First quadrant. And we're going to assume that that's theta right there. We'll just put theta there. Again, it's connected to the x-axis. We're good to go. Okay? Now, when I look at this, the sine would be opposite over hypotenuse. But you'll notice there is no hypotenuse, but there is my imaginary friend Benjamin. Right, Benjamin? That's right. Hey, you want to play a little piano for me? That's right, Benjamin. Good job. Nicely done. Okay. So back at it. Opposite with x minus 1. Hypotenuse would be 1. So now what I need to do is I need to figure out what the adjacent side would be. Okay? You might say, why? Well, ultimately, I know that I'm trying to find the cosine of this angle. I don't need to find what the angle is. All I need to figure out is what is the cosine of that. So the adjacent over hypotenuse. Okay? Now we already know hypotenuse, which is 1, but we need to find the adjacent. So to find that adjacent side, what we can do is we can do 1 squared equals a squared plus x minus 1 squared. Okay? Now the goal is to solve for a. So to do this, we want to subtract x minus 1 squared. We want to subtract it. Bring it over to the other side. Okay? So when I do that, boom, gone. And now I've got 1 minus x minus 1 squared. But I'm going to do this just on the side here. I'm going to go x minus 1 squared just to make sure. Let's multiply this out. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. So I'm left with x squared minus 2x plus 1 in there. And then also, but remember there's a negative sign there. So what does that do? Yeah, that changes this sign, and this sign. Okay? And then also remember that 1's on the outside there. So finally, when I look at it, I cancel my 1's out, 1 and negative 1. And now I'm left with a squared equals negative x squared plus 2x. Again, if I'm confusing you, please stop me as soon as possible. So I square root both sides, a is equal to the square root of negative x squared plus 2x. Okay, negative x squared plus 2x. All right? All right. Perfect. So if that's the adjacent side, square root of negative x squared plus 2x, what I can do when I find cosine So I plug it in, square root, I'm sorry, of negative x squared plus 2x. Since it's all over 1, I know my answer will just be simply square root of negative x squared plus 2x. That'd be my answer right there. All right? Alrighty. Hopefully that makes sense to you. That's a great question. That was a really good one. We've got about 30 minutes left, my YouTube followers, until it ends it for us. The YouTube channel actually will end it for us, so we've got to make sure we're done in 29 minutes. I may end it a little early because I do have some stuff I've got to get done with, but I will go over these. If I don't hit your question, apologize. I will get to those at a later time, okay? All right. It says, can you do a problem for the extra sheet? If so, number 1. Yes, Patty, I want to do that. I actually did not bring it. Would you mind just texting me that problem? So I'll go to a different problem, Patty. I'll come back to that extra sheet one. You'll be next on the dock there. Then we'll go from there. I've done number 5. Patty will be number 1. I'll do. Done number 9 there. Hunter's got one. Number 12. Let's look at number 12. It's a good one here. Number 12. Oh, 12, actually, Hunter, we had already done that one next to me. Number 12 has already been done. If you would like me to come tomorrow morning, if you want to come in, we can look at number 12 at a later time, okay? Again, right here, this is number 12. The big thing to note, this is just review for everybody. When I do tangent, I set them equal to pi over 2 and negative pi over 2, meaning I set x minus pi over 4 equal to pi over 2 and negative pi over 2. And with this one over here, when we do it, we solve for what x is. Once we do that, that's our asymptotes there, okay? All right? All right. Let's do this. Someone said number 6. Number 6, okay. Let's do that one. Number 6, we'll kind of go up yonder here. Okay. Here's what I'm going to do, too. Hey, how about this, Hunter? Do this. Take a screenshot of this, okay? I'm going to give you just a second just to take a screenshot of this one, and then I'm going to go forward, and each one you could take a screenshot for. I'll just stop it every 5 seconds. Take a screenshot of these if you desire to do so. It might help you with some of these, maybe coming back at a later time, okay? So again, if you feel like you need to take a screenshot, come back to it. Feel free to do that, and then we'll go forward on that one, okay? And then one more. All right, number 5. All right. True, can you go back in the video? Can you really? Oh, that's awesome. So can people already, I'm guessing, can people actually watch this over again, I wonder? That'd be awesome if they could. That'd be awesome. All right. Oh, that's awesome. Yeah, you can rewatch other ones from earlier. Patty, you're awesome. Thank you so much. Yeah, I didn't even think of this one. All right, let's look at Patty's. It says a jet flying at 1,000 miles per hour has a bearing of north 52 degrees east, okay? North 52 degrees east. So here's 52 degrees. You're good here, 52 degrees northeast, okay? So think about it this way. If I'm doing northeast and it's 1,000 miles per hour, okay? The important thing to note that with bearings, when I do north 52 degrees east, you literally do it the way it says. So I go north first, I go 52 degrees, and then I'll go in the east direction. So that's why I have what I have here. Now when I do this now, you see the triangle that's connected to the x-axis with theta as my angle of elevation. I notice that I can figure a lot of this stuff out because after I look at it, I notice that it says after flying for 3 hours, how far did I travel to the east and how far did I travel to the north? Okay, east and north. So now I look at that and say, all right, 1,000 miles per hour, north, and then east. All right, but this is miles per hour. This doesn't have anything to do with miles. But if I travel for 3 hours, how many miles have I traveled? So if I go 1,000 miles per hour, and I go, when I go 1,000 miles per hour, I do for 3 hours, I've traveled now a total of 3,000 miles. Okay, 3,000 miles. So if I travel 3,000 miles, that's 3,000 miles as it's increased both east and north. So in this direction would be, yes, it's 1,000 miles per hour, but it's actually 3,000 miles. Okay? Again, if you're confused, please stop Now, since this is 52 degrees, we don't know what theta is, but we know 52 plus theta equals 90 degrees. So what we could do is subtract 52 on both sides to where theta would then be equal to 52 or 90 minus 52, which would end up being 38 degrees. Okay, 38 degrees. So 38 degrees would go right in here. Okay, that's my angle of elevation. So as I elevate up, what I could do is find what the sine is. So I could say sine 38 equals opposite, which will just put us n for north, over hypotenuse, which is 3,000. We could also do cosine. Cosine of 38 equals e over 3,000. I'll multiply by 3,000 on both sides. Okay, get it going there. I love when I cancel stuff out, y'all. Maybe it's the one time where I feel like, man, I am 6 feet tall. And you know what? I can say that right now without you all making fun of me, because I can't. Guess what? I don't have to read your text messages. So if you say, "Hey, coach, you're short," that's fine. You can say all you want right now, but I can just say that I feel like I'm 6 feet, 6'5" after I cancel these. That's all I got to say. 6'5". So now 3,000 cosine of 38, 3,000 sine of 38 gets me what the miles are in terms of the north as well as the east. So when I plug that in, I'll get my miles for the north as well as the miles for the east there. Okay. Again, because I've got so many things, I've got my tablet, my Mac, my iPad and stuff. I don't have my calculator on me, so make sure you know how to plug it in and make sure that it's in degree mode. That's important. Okay, make sure it's in degree mode when you're doing that. Okay. All right. Great question. That's a great one. Okay. All right. Sweet. Sweet. All right. So here's what I want to go to. All right. Again, you can watch those problems earlier. I got Patty there. A little shout out there. Hunter got it there. Number 3 was next on my queue for a question on this one. So we'll look at number 3. I think Griffin has had one waiting, and I apologize, Griffin, if I put you on the back burner there. We'll look at number 3, and then we'll look at Griffin's one when we are done. All right, so this one, again, I don't have any of the stuff with me, but what we can do is just set it up for you. So we know that we have the triangle here. We have 90 degrees in this area. We have little a, we have little b, we have little c. That means big B is across from little b, big A across from little a, and big C across from little c, okay? So what I want to do is when I set this up on number 3, I know that C is 15, and then it also gives that angle A is going to be 38 degrees, okay? So to help us out, what we want to do is if I do the sine of 38, what I can do is say sine of 38 equals opposite over my hypotenuse. Again, if it helps you, you might want to put like little O, little a, put a circle around it, and hypotenuse. That may help you to see, oh man, I don't know my opposite, but I do know my hypotenuse. So I can use that there. So multiply by 15 on both sides. 15 to get opposite is equal to 15 sine of 38. Okay, to find what A is. I can then look at it and say, all right, how do I find B? Well, very similar. We're going to find cosine of 38 equals adjacent, which is B, over hypotenuse, which is 15. So when I multiply by 15 on both sides, little cancel party, B is equal to 15 cosine of 38. So my answer, when I solve for this, you would get 15 sine of 38, 15 cosine of 38. Make sure your calculator's in degrees. And then finally, at the end, to find what my angle B is, I would just say 90 plus 38, all subtracted from 180 to get what our answer is. And I think this one would be 52 degrees. Check me there, but I think it should be 52 degrees, okay? All right. All right, let's see. Yeah, we could do a little quiz format here. Some of you might want a little quiz format. Absolutely. So here's what I'm going to do. I'll do this. We're going to multitask here. I like this. This is great, y'all. I hope y'all like this. Please, if you don't have to text right now, but I really enjoy. I think this is going to be really good. Okay. You could come as early as 7:15 tomorrow. 7:15. I get there earlier. If you want to come in earlier, That's fine. If you want to come in by 7, that's fine. 6:30, you come by 6:30. What I probably will do is, if I were to actually help you, to actually stop, would be about 7:15 to when I would stop and help you. But I get there around 6:30 just to get set up and kind of have some quiet time before we get started in the day is usually what I do. So again, you could get there early on that. That's no big deal there, okay? Griffin had one earlier, I think. Griffin, no, you didn't have one. You just wanted a quiz there. That's fine. Try this one then. Let's do this one. Let's do number 3 on the review sheet, okay? And let's do the number 3 on the review sheet, the ones that are the no calculator ones, all right? The no calculator ones, number 3 on the extra review sheet, I should say. Extra review sheet, number 3. Take a look at that one and go from there, okay? So I'm going to come back to that one, number 3 on the extra review sheet, and I'll get to that one. Let me make sure. Some of these I want, again, I've tried to hit every one of them. If I haven't gotten to yours, again, don't get offended by that. I want to make sure I help you out however I can. Some of these might be, like number 13, I see number 13. Anytime someone just said, thanks, Coach, helped a lot, appreciate you. Thank you so much for watching on my podcast followers. All right, let's do number 13. While we're, again, some of you are quizzed on that. Let's do this. If you are, let's hold off. Let's do 13 on 13. 13, A and B. We're going to do those in just a second. So, but if you want to, you could try to attempt to do them. Just a little quiz here. We'll do this. We'll give 3 questions. Question number 1 is number 3 on the extra review sheet. Okay, it's this one right here. This will be the number 13 one. All right, so you kind of self-assess yourself. We'll do this one. No, number 1. Number 2 will be that one that I gave that was extra on the extra review sheet. All right, we'll do the one that's like arctan 1, cosine inverse of square root of 3 over 2. We'll look at that one. We'll look at sine inverse of 1/2. And then we'll do cosine inverse of 0. So all of these we're going to take a look at here. And so again, yeah, we'll take a look at these. So this will be 2 kind of quiz questions. See if I can pick one more that might be good. Trying to see here. Perfect. Someone said need extra help. See you in the morning. Fantastic. Thank you so much. Appreciate you for today. Means a lot. Really does. Okay. Let's do one more. Let's go to number 15. Yeah, number 15. Number 15 on the normal one. I'm going to do these 3. I'm going to finish off with these 3, okay? And we'll finish off and go from there, okay? So number 15. All right, so if you're quizzed right now, what I would like for you to do is I'm going to go over these 3. Hopefully they help you. If they don't help you, what I'll do is tomorrow morning we'll hit that up. But let's just assess these and go from there, okay? So again, on number 15, I'm going to write this down. But once I do that, I'm going to go back to my original one. Hopefully all my talking has given you some time to work. Try to see, hey, are you getting this stuff? Is there stuff that maybe you're missing? And if so, maybe we can kind of smooth and iron it out a little bit, all right? All right, let's do these 3. Let's start with this one first. First of all, again, the whole range thing becomes really big because when I know that from 0 to pi, that cosine inverse falls, that makes a big deal as far as the second and fourth one is concerned. Because if you look at a unit circle, square root of 3 over 2, there are 2 values where square root of 3 over 2 is cosine. But again, remember, we've got to make sure that it's within our range. So I look at it. I say, all right, where's square root of 3 over 2 positive within cosine? Well, I know that if I remember the unit circle, that there's a point where it's square root of 3 over 2 comma 1/2. Remember, cosine's related with x. So that second one, I know that this would have to be 30 degrees. Okay? At 30 degrees. So 30 degrees would be square root of 3 over 2. So when I do 30 degrees, I'll end up getting pi over 6. Pi over 6, just like that. So 30 degrees, when I take it to radians, will end up being pi over 6. Okay? Now look at cosine inverse. Cosine inverse is at 0. Again, we want to make sure. All right, we got to kind of think this through. Okay, where's cosine going to be 0? Well, we know that it's going to happen at 2 places. It'll be at 90 degrees. Okay, and it'll also be at 270. Well, the only one that falls in is within that 90 degree range. We know that because it's at 0, positive 1. So we know 0 is, again, that x corresponds with cosine. So we know that at 90 degrees, or remember with radians we have to put it in, at pi over 2, cosine inverse is 0. Okay. Now let's look at sine inverse. Again, this time both sine and tangent are from pi over 2 to negative pi over 2. So if I looked at where sine inverse would be 1/2, I could look at that and say, okay, we know that 1/2 is positive. So where is sine going to be positive? Well, we remember that the last time we had square root of 3 over 2 1/2, which was what we had up here. That was at 30 degrees. And the reason why I look at this one is because I'm looking at the y. So where is y going to be 1/2? That'd be 30 degrees or positive pi over 6. Okay. Now, if it was below, remember it would be negative pi over 6 if it was like negative 1/2. If it was negative 1/2, it'd be negative pi over 6 in that way. All right. The question now becomes, what is arctangent of 1? Instead of this time, let's do negative 1 just to kind of throw us off a little bit. We look at this and we know that at a point square root of 2 over 2, comma square root of 2 over 2, that if we did y over x, which is tangent, y over x, when it corresponds to 1, would be when it's the same thing. So it would be at 45 degrees. But because this is negative 1, we know that it's negative 1 because I kind of changed the value there. So I'm going to go all the way down to the bottom. I'm going to have 45 degrees here, but it's negative because it's going in the negative direction. So at 45 degrees or negative 45 degrees, I should have, it'll end up being negative pi over 4. Okay, so pi over 4 would be up, negative pi over 4 would be in the downward area. Okay, I had another great question. D on number 3 is tangent, not cosine. So where's tangent 0? Well, remember we're doing y over x, right? So even if we did tan inverse of 0, yeah, I got you on that one. Yeah, we're just putting that in. I just got a text from someone too. I apologize for that. You know, sometimes Michael Jordan misses a shot every once in a while. You know, it's not my fault that sometimes, you know, just mess up a little bit. Okay? Sorry. All right, so no, I'm just messing. So once I do this, I go y over x. Where is it going to be y over x equal to 0? Well, I look right here, and I know that at 1, 0, 1, 0, that if I did y over x would be 0 over 1, right? Well, that again, a 0 on top would be 0. So tangent inverse of 0 would end up being, guess what? Hold your breath, 0 degrees. Okay? 0 degrees there. All right. Excellent, 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 excellent. Look at number 15. Okay, number 15 is one where when we actually let's do this. Let's go backwards to this one. Hey, remember this one when I'm setting it up. Where's arcsine going to be positive? It's going to be in this direction. Theta is here. Opposite over hypotenuse. Opposite's 3. 7 is hypotenuse. So when I do this, I'll get 7 squared equals 3 squared plus a squared. We'll just say this is a. So then I set it up. 49 equals 9 plus a squared. Subtract 9 on both sides. Subtract 9. 40 equals a squared. And if I square root it, I should get a is equal to square root of 40. Again, I need to simplify this. Is there a pair? There is. Because again, you think 4 times 10. I can take the square root of 4, which would be 2. So it should be 2 root 10 as my adjacent side. So if I was doing my tangent, tangent's opposite over hypotenuse, or opposite over adjacent. Opposite's 3, adjacent's 2 square roots of 10. I don't like that square root in the bottom, so I'm going to multiply top and bottom by square root of 10. So I should get 3 square roots of 10 all over 2 times 10, because again, that was canceled to get 20. Okay? So it should be 3 square roots of 10 all over 20. Remember, I can't divide that out, 10 and 20, because one's under a square root and one is not. The next one, similar, very similar. Adjacent is 4. 9 is hypotenuse. Remember, arc cosine, where is it positive? It's positive in the first quadrant. So now I'm looking for my opposite side. So when I'm looking for my opposite side, I know that I do 9 squared equals 4 squared plus x squared. We'll say this is x, I'm sorry. Say this is x squared. So 81 equals 16 plus x squared. Subtract 16 on both sides. X squared equals, then I'll simplify it. I think it should be 65. I think 65, yeah, it should be 65. So I'll square root both sides. When I square root a squared, it could be plus or minus, but because it goes up, it'll be positive, square root of 65. So then my question is, where does sine of this angle theta? It'll be opposite square root of 65 over hypotenuse, which is 9. Okay? I know I did that very quickly. Just trying to wrap this up here. If you have more questions, please let me know. Okay, last but not least, all right? And again, I'm going to wrap this one up. I apologize, I'm going quick. And this one, amplitude, would end up being 1/5. So this is what I'm looking for. I know it gives all the mess on number 15 on things I need to find. My big thing is this. What are my asymptotes? What is my vertical shift? What is, in vertical shift, we kind of say is kind of the center line there. And that sort of thing. Well, we'll just say this. This is what I'm expecting. So amplitude's 1/5. We know it's no reflection, so we don't put that there. Vertical shift is -2. And I had a question, can we use a note card? Unfortunately, no, there shouldn't be really anything we need a note card for. I will give you the first quadrant of the unit circle, but everything else should be processed as we should know. Okay? So thank you so much for asking that. So I've got these two right here, amplitude and vertical shift. So what I'm going to do is set 3x minus pi over 3. We're going to set that equal to pi over 2 and negative pi over 2. Now, again, if it was cotangent, it would be 0 and pi. So you might want to just kind of put that. If it was cotangent, I'd set it equal to 0 and pi. But since it's tangent, that's why I set it equal to negative pi over 2 and pi over 2. So now here comes the tricky part. I want to add pi over 3 to both sides. Okay? To where I get common denominators. Let's put this as 6. Let's put this as 6. Same thing over here. I multiply the bottom by 3. Let's multiply the top by 3. Multiply bottom by 2. Multiply top by 2. Okay, same thing here. Let's bottom, let's be 3 pi. Let's be 2 pi. Okay? Now 2 pi, 2 pi. So 3 pi over 6 plus 2 pi over 6 should be 5 pi over 6. So right now I should get 3x equals 5 pi over 6. Okay? Over here on this side, when I subtract, I should get negative pi over 6. It's still equal to 3x. Okay? So 3x equals negative pi over 6. So if I divide by 3 or multiply by 1/3 would be the same thing. Again, I'm right here, and I'm right here. Multiply by 1/3. I'm running out of room. What I can do for this one then is then say, all right, 5 pi times 5 pi over 6 times 1 over 3 would get me 5 pi over 18 would be one asymptote, and the other asymptote would end up being, I'm going to make sure 100%, to be negative pi over 18, okay, when I multiply. Negative pi over 18. So again, I look at that, I'm good to go. I solve for both of my asymptotes. If you really want to solve for the period, just find the distance between the two. So if I go from 0 to 5 pi over 18, I add 5 pi over 18, but then I add one more because I go in the negative direction, 1 pi. So what I'm going is 6 pi over 18. I've traveled 6 pi over 18. So now, in setting this up, I can reduce it to end up getting pi over 3. Another good thing that you could do is whatever value's here, just put pi over that. So you could find the period by doing pi over whatever this value is, which would be 3. So you get pi over 3, which is the same that we just found. Okay? Again, I hope that was helpful for you. I hope my podcast, the people on the YouTube channel, was helpful. I appreciate it. Again, if there are more questions, please, please, please come in tomorrow morning. I'd love to help you out. For the test, we'll have about 10 minutes to prepare, and then we'll rock and roll from there. Hopefully everything was clear today, and we were good. Awesome. Y'all are amazing. Great job. Yeah, I appreciate y'all, man. Y'all are absolutely fantastic. And we'll go from there. Um, Chris, shout out. I know if you're still here. Hunter, Zach. I'm looking over at the side at the questions. I can't see the questions when I'm doing the whiteboard, but I really do appreciate you on that. Hope this was helpful. Y'all are great. Y'all are awesome. Peace out. Good luck on the test tomorrow. Bye.